Welcome to CS207, lab number 6. This week's lab brought to you by Voluspa. Consider the Baltic Amber scent. It's beautiful and will make your home smell great. Of course, I'm just kidding. We're going to be working with great things in small packages, but our small package is going to be a servo motor. In this case, the Hextronic HXT9000. We're going to open this puppy up and see what's going on the inside. 9-gram servo, it says at the bottom. That means that it weighs 9 grams, but it can move 1.6 kilograms at 1 centimeter. But first, you need to understand how the wiring works. So let's take a look. The brown wire on top is for ground. In the middle is 5 volts, and on the bottom, the lightest color wire is our PWM signal. Let's see if I can get this case open. This is really fussy work. I purchased a set of very small screwdriver bits for working with electronics, but you know, my fingers are still big. And there's the first one. Fast forwarding time here. That's 3 out of 4 and 4 out of 4, and here we go. What's inside the case? Oh look, it's a circuit board. I am so surprised. Let's take a look at what's underneath that. Oh, by the way, do you see those little cases marked 0? Those are 0 value resistors. Basically jumper wires that make it easier for robots to assemble these boards. Let's take a look. What kind of a chip is this? Let's try to get a closer look. So our servo is driven by an AA51880. The PWM signal that goes into your servo will arrive on the pin marked 14 here, voltage in. This is a varying voltage signal with highs and lows. It creates a square wave, the PWM wave. The longer it's high, the higher the angle that we want the servo to go to. This value is lined up with another square wave that's generated internally based on pin 15, which is attached to the potentiometer underneath the drive shaft. That voltage creates another square wave lined up with the first one, and then those two square waves are compared to see which one is high for longer. And then the motor will be controlled to go one way or the other based on that. The pulse stretcher below the PWM control allows the creation of a dead zone where if the servo is close enough to the right value, it won't move. But if it's outside of that dead zone, then it will move. The PWM controller is then connected to the output driver, which will turn on combinations of 4 pins to drive the motor in the right direction. Out 1 and out 2 can be used by themselves, one being high and the other low, to drive the motor in one direction or the other, and they can both be set to high or low if the motor doesn't need to move. If you need more power, you can add an external H-bridge. Out 1 and EXP1 would drive the H-bridge in one direction, and out 2 and EXP2 would help drive the H-bridge in the other direction. That's an awful lot of functions for one little chip to do, and I personally am grateful that I'm not responsible for all that wiring. That all I have to do is literally say, go to this number, and the servo will automatically try to make that potentiometer make this shaft go to the right place. Let's take a look over here on the other side. That's a motor. This motor is almost exactly like the one that you worked with in Lab 5. It's just a little bit smaller and it's got a gear set on the top that drives that set of cogs, which will cause the shaft there to go to the right location. And that, of course, is connected to the potentiometer that we saw inside earlier. So that's all there is to it mechanically. It's convenient and easy to use. So now that I've pulled it all apart, let's see if we can get this thing to work again. Finally, last screw. Now, this thing I'm putting on top, that's a horn. It will help you and your TA to see what direction the servo is pointing. They come in one-sided or two-sided versions. In my lab notes, I will be using the one-sided version. This is just the one I had on hand. You don't need to attach it with the screw unless you're actually trying to control something. So here's my Arduino. I've already got most of the wiring for this week's circuit ready to go. I'll just plug the cable for the servo into my breadboard. And I've added a special header, you'll see it in a moment, to make it easier to plug it directly in. There we go. And yes, it looks like I did not break my servo when I did the demo. Fantastic. I still have a whole bunch of them to give out if people need them. Now let's take a closer look at the wiring. This orange wire over here is connected to the orange wire on the servo and is sending out PWM signals. The red one is 5 volts and the blue one is ground. It's as easy as that. Now, your servo is going to want to wander all over the place, and the cable makes it hard for it to stay upright, so you'll probably want something to help hold it still, especially if you're moving it around fast, if you're not having slow commands to control it. So, yep, there it goes. I'm going to find something to help my servo to hold itself in place. These little things here are called headers. There should be 4 of them in your kit. They were given to you with the intent of holding down the little paper circuit guides, but I'm going to use them to hold my servo. You also have a 3-pin header, which you can use to plug your servo into the board. Like that. And now I'll show you how I use the other headers to hold the servo in place. First, I make a sort of a top and a right edge for my servo, and then I put the servo down and make a note of what bar number the other side of the servo is in. And I establish the other side. And this will sort of hold the servo in place. It may shake around a little bit, and if you tug on the cable, it'll still fall over, but it's much better than just letting it wander around by itself. There we go.